Okay, let's talk about powers or indices. It doesn't really matter. Both of them are valid terms to call these things, these superscripts on numbers. And we have 10 laws that we know about powers. Right. So let's talk about each one in more detail. But here is a list of all 10. Right. So the first one is the multiplication law, and it basically, okay, one. The multiplication law says that if you have a number a and raised to the power of b, and you multiply it by 1 raised to the power of c, you get a to the power of b plus c. So you add the indices when you multiply together. So for example, 2 squared times 2 cubed is equal to 2/5. Or more commonly we'll see this with algebra. So we'll get x to the 3 times x to the minus 5, for example. And we add these together, so that will be x3 plus minus 5. So it'll be x to the minus 2. Those are our examples. Similarly, we have the same case for division, but instead of adding, we subtract. So let's do just one example for this. So we could have, or actually, we'll have x to the 4 divided by x to the 5. It'll be x to the minus 1, because I'll show you that it's 4 minus 5. Just x to the minus 1. Another one would be, let's do something like this. The 7 over x to the 3. We can see that we're still dividing here because we have the fraction sign. So it's the same as x, 7 to the power of 7 minus 3, so x to the 4. There. Okay. Now our third rule, so we have the multiplication law and the division law. Third rule is the multiple powers law. It says that when you get a power and then you put it to another power, it's the same as multiplying those powers together. So we can actually multiply now. So for example, if we have 2 to the power of 3 squared, that's the same as 3 times 2. 2 to the power of 3 times 2, which is equal to 2 to the 6. Like that. Right, actually, let's do another one. We could have something like that, and then you just have to use, like, it's not, you can use these, the exact same rule. Doesn't matter what letters are used. That's what I'm trying to say. Right, so those are our 3 rules to begin with, and now we have our power 0 law. And that's basically anything to the power of 0 is equal to 1. No matter what a is, it's always equal to 1. So obviously it's quite difficult to come up with like different examples, but like we could have 2000, just basically an absurdly high number, put it to the power of 0, we get 1. And we can make that negative. We could even like square root that number or something like that. So long as if it's to the power of 0, it's 1. That's all I'm saying. Okay, let's move to a new page. Rule 5 is the power 1 law. So it's a to the power of 1 is a. So anything to the power of 1 is itself. So what we could say is minus 56 to the power of 1 is minus 56. Surprise, surprise, 1 to the power of 1 is 1. So yeah, anything to the power of 1 is itself. Okay, so rule 6 is the 1 law, and that's when we put 1 to any power, a, or x, I think I used before, we'll get 1. And that kind of makes sense, because when you when you use powers, you're saying I want to multiply 1 a times, so you'll do that a times, right? But obviously it doesn't matter how many times you multiply 1 by itself, you're still going to get 1. And again, what we can do is we can use a really absurd example to really hammer down the point. And yeah, that looks really complicated, but it's just 1. Right, yeah. Okay, the 7th law is the fraction law. That basically says this. Like that. So, and basically what that means is if you're squaring a whole fraction or putting a whole fraction to a power, you do it to the numerator and the denominator. So for example, we can, and just heads up, the reason why this works is, again, we're multiplying this c times now, right? So obviously all the numerators will multiply together and all the denominators, and that's why it works. You don't need to know why they work, you just need to know the rules. But and also why this works is because we're saying we want to multiply a by itself 1, like we just want 1a, because a squared is 2a times by a, but a1 is just a by itself. Right. So for example, what can we do? Right, let's have a mixed fraction like that. So to change this mixed fraction into an improper fraction, we have to multiply 4 by 2 to get 8, and then add it to 3 to get 11. Like so. And then that will be equal to this. And that, obviously you could put that even simpler, but that'll be a horrendously large number, so I'm not going to do that. Alright, the next bit is the roots rule, and it basically says if we had a function fx, which is a to the power of b. By the way, if I word it differently over there, like on the first slide, but this also works. The inverse function will be root b a. We put this here to say it's the bth root. Basically what that means is if root ba equals k, or c, let's say, that means that a equals c to the b, because they're inverses, like that. And yeah. But that's basically how you do it. So for example, if you had a cubed equals 8, we could apply, like how, for example, actually, let's do a squared let's do a squared equals I don't know, 9, right? So that this is eg1. Oh no, these are just egs. The inverse for that, because b would be 2, the inverse for that would be 2 a squared, but when it's 2 we just don't write it, we just assume it's 2 when there's nothing there. It's a square root, and then we square root both sides, and then we get a equals 3. But now if we, for example, if we had a cubed equals 8, we can't square root both sides because that's not the inverse of this function. Instead we have to do the cube root like that. to cancel out. And the cube root of 8. What is the cube root of 8? Basically, you have to say what three numbers, let's say x times x times x equals 8. And basically the answer will be 2, because 2 times 2 is 4, times 2 again is 8. So it would be 2. But you can put that in your calculator. I don't think you're expected to know cube roots or anything higher. To put it in your calculator, just press shift and then the square root, and you should get a cube root. You can also do, if you do that, you can go backwards, delete the 3 and put in any number you want. Yeah. Alright, so rule 9. Okay, rule 9. Give me a second. Right, fractional powers. So a to the power of b over c equals the cth root of a to the b, like that. So this seems kind of it might be quite difficult to wrap your head around, but let's do some examples. So x to the power of a third is equal to, well, c is 3 in this case, so it's a cube root, and 1, b is 1, so we just get x inside, so that's our answer. Yeah. We could also have 2 over 2, which equals the square root, sorry, we don't have to write 2 though, of x squared. But wait, those are inverses. We just get x. Of course they are, because 2 over 2 is just 1. And x to the power of 1, as we learned, is always x. Let's try it with an actual number. So 64 to the power of 2 over 3. So let's put it in that form first. Like that. Now first, let's do the root. We always do the root before the square. So what is 64 cube rooted? Well, it's actually, well, what three numbers multiplied together to give 64? Well, it's 4, like that. So 4 times 4 is 16, and then obviously that equals 64, like that. So yeah, so the answer to that is 4, and then all we have to do after that is square the 4. So we cube rooted it first, and then we square the 4, giving us 16, and that's our answer. Just a few cube roots that might be useful is 2 to the power of 3 is 8, 3 to the power of 3 is 27, 4 to the power of 3 64, 5 to the power of 3 is 125. You can learn these, or what you can do is in the exam they'll never give you a really difficult cube root. You'll just have to use trial and error and you'll get there. Our final rule is of negative powers. So our negative powers is this rule: a to the power of minus b equals 1 over a to the b. In other words, what we say is this minus goes to 1 over, and then we keep the power there. For example, a to the power of minus 1 equals, well, this minus 1 goes into 1 over, and then we just do a, like that. Or 10 to the minus 1 will be 1 over 10. We just change the minus 1 into a 1 over. There's another, you can also think of this as if we have a to the b minus x, well, it'll be 1 over a over b x. But if we have 1 over a fraction, we can just flip the fraction. We have that. So we say when we make a fraction negative, we flip the fraction. When we make the power negative, sorry. Okay, let's do some examples then, just on all of it, all the rules we've learned. So, how can we simplify this? In fact, I'll do ED1. Well, what we can do is, remember, we have this negative, so let's put it on top. We have 4 cubed, and remember, we've learned that 4 cubed is 64. So that is our answer. The next thing is 9 to the power of 3 over 2. Well, what we can do is we can use the fractional indices rule to get us to 9, square root of 9 to the power of 3. And that equals, the square root of 9 is just 3 to the power of 3. And again, we're cubing 3, which we know is 27. Okay, e.g. 3. We have 8 to the power of 2 over 3. And again, we have to put this at the top, so we get 1 over 8 to the power of 2 over 3. Let's isolate this. So we can use our fractional indices rule to get that. And then the cube root of 8 we've learnt to be 2. So we just have 2 squared. In fact, a better way to write this would just be to square the whole thing. So you'll never get mistaken on what to do first. You always root first and then you square after. So you cube root this and then you have 2 and then 2 squared, which is 4. But remember, that's not our answer because it's 1 over 8 to the 3, so we can put this like in a bubble, and then so we get 1 over 8 to the power of 2 over 3 equals 1 over 4. Final example, but first I just want to go back to the rule and just stress that the better way to do this probably be to bracket the whole thing and then put the power like that. The last thing is this there's this type of question which says that 2 to the power, you get something like 2 to the power of 15 times 8 to the power of minus 4, and say write this as a power of 2. So what we need to do is we need to realize here that 8 can be represented as a power of 2. It's just 2 to the power of 3, right? Because 2 cubed is 8. And remember, from our bracket law, we can change that to be 3 times minus 4, which is minus 12. And because of our multiplication law, we know that that's just 2 to the power of 15 minus 12. It's 2 to the 3. Oh, right, we can just write 8 like that. Okay. Now you can have a go at some exercises. Try writing 9 to the power of 5 times 3 to the power of minus 5 as a power of 3. In fact, we wouldn't write this as 8 because it wants it in as a power of 2. So this is what we want. 8 is not a power of 2. My bad. Find root 9 times 6 squared. And finally, find 8 to the power of minus 5 over 3. Okay, or it won't be find, it'll probably be, it won't use the word find, it'll be simplify, because you're making it simpler. Okay. Good luck.